Yeah, give it a couple seconds and then you can just jump right in. Feel free to share your screen as usual.
Okay. Are you going to do any sort of intro spiel or?
Yeah, I got you.
Okay.
All right. Hello, everyone. If you're... Oh, wait, I can hear myself. There we go. All right. Hello, everyone. Thank you for coming in. Welcome to our last team pitch of the season. Today, we're hearing from OpenGD and my boys, Jimmy and Daniel. I will let them take it away. As usual, if you have any questions for them or for me, feel free to message anybody on Slack. Nothing different there. All right. Go ahead, guys.
Thank you very much, Hansh. Let me share my screen.
You're welcome.
Here we go. OpenGD, or otherwise known as Open Gun Detection. So what is our product? Basically we identified a problem of whenever there's an armed gunman in a mass shooting or any sort of situation where there's some potential gun violence, first responders are kind of hindered by the speed at which they're alerted. Basically it has to be identified first and then it has to be called in with 911. Basically, it's not a great system. So additionally, they're unable to accurately pinpoint the location of a gunman on a large campus where, let's say, some gunman is in the middle of a school, but authorities are unaware of where exactly the gunman is. So our proposed solution is to create a fast and accurate and relatively computationally inexpensive gun detection system that can hook into existing CCTV cameras. And once there is some sort of detection of a gun through our system, security personnel can be quickly notified. So what did we do basically? And the road, a very long and arduous road to a relatively performant model. So we started with YOLO version 4, which is the latest version of the computer vision framework, YOLO. And we started with training on 3,000 handgun images that are open, that were cataloged from the University of Granada. There were some duplicates, so we had to sort through those, but after doing so, we bootstrapped with the COCO dataset and Google Open Images dataset to add in hard negative images to lower the false positive rate. You can see in the diagram how exactly bootstrapping works, and it's a very simple concept of basically, after training, you test on a large variety and a large number of images that are negatives, and the images that are identified as positive by the model when they're supposed to be negative are added into the training set. So then we further added around 2,000 images from a synthetic gun data set. Basically, they were generated in Unity with 3D models and in a wide variety of different environments and different lighting conditions. But the only downside to using synthetic models or synthetic data is that you essentially run into issue of this reality gap where you train on synthetic data and then you run on real data and there's some sort of gap between the reality. And in order to mitigate this, we first trained on the synthetic gun data set until we got our highest map value, which is the mean average precision, basically a metric for performance for a model. And then using that as the starting point for training on real data, which vastly outnumbers the synthetic data. Then we also added additional data from Google Open Images, as well as various clips online. And after around 30, maybe more training and testing rounds with different data, different hyperparameters such as network resolution and data pre-processing methods, we achieved acceptable real-world performance at a mean average precision of 98.53% on validation data set of 299 real gun images and 935 mined hard negative images. So what are our project features? So we can achieve real-time gun detection at around 82 frames per second on standard NVIDIA 2080 Ti. What this means is that you can take probably up to 8 feeds running at 10 frames per second. for detection purposes, instead of just running on obviously one feed at 82 frames per second, that's excessive for detection purposes. So, but this means that our model is fairly performant in the sense that it can run multiple video streams using just one GPU. As we stated before, we achieved accurate and precise detection of handguns. We also created a system to have audio and visual warnings for security personnel monitoring the feeds when a gun is detected. We also have features to automatically record and save input feeds to input feed when guns are detected. Also various options for how video feeds are displayed and recorded, as well as whether or not it's fed through a web server, so it can be accessed through a local network. Also, it can hook into existing camera security systems fairly simply, as long as the existing security system has some way of inputting the cameras through some IP system. So this is what a sample configuration looks like for our end demo. As you can see, there's a lot of options for whether or not there's web service on, whether or not it's locally displaying, various different modes for how the threshold for detection is set. To note, the red alert check frames basically says that in the X amount of frames previous to the current live frame, how many detections, positive detections were there, and based off that, we can change it to red alert. And here are some demo videos. So this was
Gym, library, gym, library, 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 library.
So these were run on a laptop 1050 Ti, so that's why the performance doesn't look great. But basically, it can run at around 17 frames per second on this relatively weak and last gen laptop GPU. And then here's another demo of the video recording and image recording features. So basically, it'll take in at specific times recordings of the last second or whatever user specified length of time. And as you can see, it's intentionally designed so that for video recording purposes, at least, there's a delay for between each recording. So basically, while you grab all the frames of detection, every time there's a recording that takes place, it'll purposely delay it by whatever duration the recording is so that you don't have overlapping video. And finally, this is a demonstration of the web version, as well as this is the detection only mode. So basically it'll only display detections rather than all the frames. And as you can see, it's outputting at all of the native resolutions of the input feeds. That's why when you zoom in, it's still 1080p. And again, the performance isn't great because it's running 4 streams on a laptop GPU. Okay, so for our results and ongoing challenges, so we succeeded in our goal of creating a performant, free and open source real-time gun detection system that can help lower the response time to potential gun violence and affordably increase the security of soft targets. What's key here is there are, in our research during this project, we found that there are a few startup companies working on the same problem, but their costs of their systems are quite high. And honestly, I feel like this technology should be available to as many people as possible, rather than charging lots of money just for this feature. And then our ongoing challenges are essentially the detection system still struggles with guns that are further away. So essentially, the reason for this is since the gun is further away, there's less data to be like inferenced upon. And because our model is relatively performant, however, the more feasible strategy is to just simply add more cameras in a given space because cameras are relatively cheap. And the performance gains from trying to train a model at a higher resolution are not really worth it because you'll see maybe a few percentage point increases, but at the cost of a great deal of performance. So instead of trying to squeeze that bit of performance out of GPU by processing a higher resolution, instead we propose that you just simply add more cameras. The balance between false positives and false negatives and further reduction of both is another challenge. So while we succeeded in reducing false positives drastically from the start and throughout the process, it still remains an issue. Obviously, you want to minimize false positives as much as possible. And while like a 98% map may sound impressive, in the real world, when there are rarely any guns, you'll still see a decent number of false positives. And one way we mitigate this is through the system of the red detections, so like red alert detections. So the chances of an object being misidentified are much lower when there are successive detections. Essentially, at least anecdotally and through our testing, whenever there's a false detection, usually it's only for like a frame. So if you set the threshold of at least having like 3 frames in the last 10 frames of having a positive detection, you can reduce false positives that way very effectively. In terms of reduction of computational needs to reduce cost further, that's definitely something that can be looked into, and I'll get into that later. And then there are some questions on privacy and the systems becoming more autonomous. Essentially, when there's more autonomous systems, there's a question of whether or not people will still verify when something comes in, or how closely they'll monitor such a feed, because it's a similar problem to like self-driving cars where people abuse the system and don't really pay attention to the road when the system's not ready for like full autonomy. And privacy is an issue where if the technicians are sent to, let's say, the police or something, how do you handle such privacy issues where these feeds could be monitored? So these are potential additional features that are relatively easy to implement. So instead of altering the configuration of the file, you could have a user customized GUI. So that's better for user experience. Some sort of companion app or some sort of alert system that can notify like police or some sort of security company automatically through like the web. That could be implemented relatively easily. Multi-GPU support. So essentially, if you have a server that's running more than one GPU, we would need to add support for running the model on multiple GPUs. We also want to work on expanding the range of detection to other firearms. And this is relatively simple as long as we compile more data for other firearms, as our data set is primarily handguns. And also there's something called TKDNN, which is basically an optimization for neural nets that's compatible with what our current system uses. And we can see a frames per second speed up of up to around 2 times. And with this, with the 2080 Ti or equivalent GPU, we could probably run like 16 streams off of one GPU, which is pretty performant. Any questions?
はい、お疲れ様でした。
I'm not sure what that was. Okay, I have a couple questions. So first, have you deployed this? Have you deployed this yet?
What do you mean by deploy?
As in, is it available on the web?
Yeah, it's on GitHub and it's freely available with like the setup and everything. It's also inside of a Docker container, so it's pretty easily deployable.
Okay, sure. Well, and then let's see, how easy would you say it is for, I mean, let's say I was at the GDC or something, right? And I had access to a camera. What is the process for my linking of my video feed to your product?
So it's, if you have like a USB webcam, it's pretty easy. You just change the, basically in the configuration file, in the sources, you can change just what the source is. So right now they're all like MP4s, but you can easily change it to like an IP camera by just putting the IP and the port and the output in like a dummy JPEG format. And for webcams, you just input in the ID of the webcam.
Okay, cool. Makes enough sense. Let's see. I had another question, but I cannot remember it. So in the meantime, do you have anything?
Not really. Really cool product. I really enjoyed listening about it and seeing the demos. They're very impressive.
Thank you.
Fuck yeah, I can't remember. Okay, whatever. That's fine. If I do remember, then I guess I'll just ask it to you later.
Yeah.
Anyways, yeah. Thank you guys so much for presenting. If you're watching on YouTube, thank you so much for coming. As usual, feel free to message anybody with questions. We are always open to that. And have a great night.